Greetings and welcome to section 7.4, part 2, part B, if that's what you're looking for. Good news today. It's going to be a real quick video for you. I just really want to connect a couple ideas from the radicals. Really, inverses. Inverses are the key. You've heard me say it over and over again this chapter. Logs and exponents go hand in hand, like multiplication and division go hand in hand, like addition and subtraction goes hand in hand. These things work together. Logs and exponents is just the next step in your mathematical growth. So we're going to look at inverses today. Should be maybe a 15-minute video here. That probably will count the checkpoints for you. If I do my job right and you've been tuned into the videos, then this should be pretty quick and easy for you. Hopefully painless, so that we can get on and be successful in the next part. By the way, next part of chapter 7.4, the third part, we're spending 3 days on it. Third part will be graphing, but we're going to approach it in a way that I'm going to combine kind of everything we've done in this chapter at this point that hopefully makes some sense for you. Okay, so tomorrow will be a little bit longer video. We'll be graphing, but today, like I said, inverses, just kind of doing what should be the natural next step in the progression. A general reminder, how do we find an inverse function? First off, you flip-flop the x's and y's, and then you resolve for the x value. So here we go. General reminder, identities, those are the things. The name of the game for logs and exponents is match up those bases. Match up those bases. And that's what you guys have already been doing. We will use the idea of, I call it an identity. I'll use the idea of what I call an inverse, undoing the property in order to move it over, in order to simplify, in order to reduce. You guys have already played around with it a little bit. So this should look familiar to you. You used this on yesterday's work. So again, now we're going to apply it. First problem we're going to do, find the inverse of this function. We're looking at y equals the log of 3/2 of x, or log base 3/2 of x. Y equals log base 3/2 of x. Our goal is to find the inverse of the function. General idea, connection piece on this. When we find an inverse, we flip-flop the x's and y's, and then we resolve. Big picture idea, because it will come into play later. If we flip-flop the x's and y's, then it should make sense to you. What was a domain before is now a range. What was a range before is now a domain. So here's your sneak peek into the future. And also, here's today's secret word. Real early in the video for you today. Today's secret word is vertical asymptote. Vertical asymptote is today's secret word, and hopefully if you think about graphing, if you think about the words inverses, if you think about the words flip-flopping x's and y's, and if you've already graphed exponential growth and decay, and when we graphed exponential growth and decay, we had a horizontal asymptote, then it should make sense to you that now, if we're going to graph logs tomorrow, and it's an inverse function from an exponent, and I flip-flop x's and y's, where before I had a range restriction with a horizontal asymptote, tomorrow I'm going to have a domain restriction with a vertical asymptote. Almost as if we've been setting this up for you all along. Again, Algebra 2, done correctly, the pieces should fit together like a puzzle. They shouldn't be all separate thoughts. So, if I'm doing my job right, you should see where we're headed. We're not focusing on that today. Graphing will be tomorrow, but today I just want to make sure that we can do the inverses. If I've got y equals log base 3/2 of x, if I need to find the inverse of it, my first step should be to flip-flop the x's and y's. X equals the log of 3/2 of x, of y. Oops, I hate it when that happens. So my job is to now solve this equation for y. That means to get rid of the log base 3/2. At this point of the game, it should be very clear to you. To get rid of a log 3 halves, I need to introduce a base 3 halves to both sides of the equation. Base 3 halves to the right-hand side, base 3 halves to the left-hand side. There is a giant 1. The right-hand side of that equation simplifies to y equals, and the left-hand side is 3 halves to the x. Again, biggest mistake here, make sure that that 3 halves to the x, that x is an exponent that is not 3 halves times x. So our inverse function is going to be 3 halves, can't write the number 3 halves. 3 halves to the x. That's it? That's all we have to do? Yeah, that's it. That's all we have to do. For those that didn't finish copying, there you go. Y equals 3 halves to the x. Next one, letter B. Y equals the natural log of x minus 4. Find the inverse. X equals the natural log of y minus 4. Mr. Wood, I don't know how to match the bases up here. That doesn't have a base on it. Well, here's the tip. The natural log is the log base e. So I'll change it to log base e instead of natural log. Now you should be able to see what you need to do. I need to get rid of the log e, so I will introduce a base e to both sides of the equation. I have e to the x equals, there's my identity, I have y minus 4 on the right-hand side. Finish it up. Add 4 to both sides of that equation. E to the x plus 4 is what y equals. So my inverse function there, my inverse function is e to the x plus 4. That's it? That's all we have to do? That's it. That's all you have to do. Next one. Y equals log base 3 of x plus 5. First step, rewrite. X equals log base 3 of y plus 5. Now, I want to be very careful before I go over this next problem. I want you to look at letter B that I just did and letter C that I'm going to do right now. Look carefully at the problems and realize that letter B and letter C are very similar, but they're different. Here's the big difference. In letter B, the quantity x minus 4, the quantity x minus 4 is connected to the natural log. We know the whole thing, x minus 4, is connected to the natural log because it's told us so with the parentheses. So in letter B, in order to get x by itself, I had to first introduce the base of e to clear out my natural log. On letter C, the value of 5 is not connected to x, it's not connected to the log. If the positive 5 was connected to the x, they would have put it in parentheses. So again, make sure you're clear on B and C. Letter B, parentheses, with the quantity x minus 4. So I had to get rid of the log first. Letter C, the positive 5 is not attached to the log. So on letter C, I need to move the 5 over first. So now I have x minus 5 on the left, and I have the log 3 of y on the right-hand side. At this point, I need to get rid of the log 3. The way to get rid of a log 3, I need to base 3 both sides of the equation. I'm going to introduce a base 3 to the right-hand side and a base of 3 to the left-hand side. Here's the difference between letter B and letter C. That quantity x minus 5 is now all up in the exponent position. The quantity x minus 5 is all up in the exponent position, where on the previous problem it was not. So there's my identity. I have y. Now my inverse function is 3 to the x minus 5. Again, make sure you know what you're moving over first, and more importantly, why you're moving it over in what order. What's connected to the x, what's not. Parentheses will dictate what does what in what order. Okay? And honestly, that's really what you're doing today. So I got a checkpoint real quick, and then just one more example. So checkpoint coming up. Go ahead and pause the video. Do that checkpoint. I want you to find that inverse real quick, and be ready to roll for the next problem. Okay. Hopefully you paused that video, did that checkpoint. Make sure you bring that to class tomorrow. You'll be good to go. I got one more example that I want to do real quick. It's kind of the same thing. This is example number 2. I know it's labeled example number 5. Sorry about that. Apparently, I wrote 5 instead of 2. Example number 2. Find the inverse of the function, y equals 4 to the x. Then we're going to find y equals 5 to the x plus 7. And then y equals 7 to the 2x minus 1. Really the same game. This time we have exponents, and we need to make the inverses, so we're going to make them logs. So, same game, y equals 4 to the x. This is now going to say x equals 4 to the y. We need to get y by itself. So we need to get rid of, I'm shocked to see that now I need to get rid of a base 4. And the way that I would get rid of a base 4 is, oh me, oh my, introduce a log base 4 to both sides of the equation. I am shocked to see that the thing that I'm going to do is the inverse of the thing I did on the previous problems. It's almost as if these things go hand in hand. It's almost as if bases go hand in hand with logs, or logs go hand in hand with bases. It's almost like it's the same thing over and over again, Mr. Wood. This stuff is really easy. I don't know why it's hard. It's not. You mean if I keep just doing this the whole time, that's all I have to do? Oh. Well then, okay. So finish it up. There's our identity. We got y equals, and that's going to be log base 4 of x. And yes, ladies and gentlemen, that is your answer. Ta-da! All right, letter B. Y equals 5 to the x plus 7. Flip-flop your x's and y's. It's going to give you x equals 5 to the y plus 7. Notice that the y plus 7 is all in my exponent. It's all up in the exponent. Just like the previous problem, you need to look to see where things are located because they will tell you what you do first and what you do second. That's what students' biggest mistake usually is on these problems. So the x plus 7 is an exponent, so I need to get rid of that base first. So the first thing I'm going to do here is log base 5. Both sides of the equation. So now I have log of 5 to the x equals y plus 7. Finish this problem, minus 7 from both sides. And y equals log base 5 of x minus 7. Now that is not in parentheses because I moved the 7 over a second. It's not connected, so this inverse function is going to be log 5 of x minus 7. If they were connected, I would put parentheses around that. You're going to see this next example. They will be connected. So I'll show you what I mean by that. Again, make sure you look at the similarities and the differences between letter B and letter C. C says y equals 7 to the 2x minus 1. 7 to the 2x minus 1. Still need to find the inverse. Still need to flip-flop x's and y's. And still need to solve it for x. X equals 7 raised to the 2y minus 1. Need to isolate that exponent. So this time, the negative 1, which is not connected to that base, I will move the negative 1 over first by adding 1 to both sides of that equation. And that leaves me 7 to the 2y. Notice that that positive 1 is now connected to the x. I moved it forward. I moved it over first because I had to. That positive 1 is now connected. It's on the left-hand side of the equation. The reason I'm doing this, to make sure you're clear, is because at this point, I need to get rid of the base 7 from the right-hand side of the equation. The way that I'm going to get rid of the base 7 is I'm going to log base 7. I'm going to log base 7, both sides of the equation. Log base 7, x plus 1 equals. There's my identity, and that's 2y. To get y by itself, divide both sides of this equation by 2. And that's going to give me y equals, or y negative 1, my inverse function, equals log base 7 of x plus 1 over 2. That's it. That's what we're doing. In fact, you're just about done with lecture. In fact, there's your checkpoint. 2 checkpoints today. You've already got the secret password. Pause the video. In fact, you don't even have to pause the video. I'm going to be done here in just a second. Do your second checkpoint, and we are going to be good to go. By the way, actually, I'm going to add something to this checkpoint right now. Let's make it this. Natural log of x plus 3, I'm going to make it minus 5. Okay? Natural log of x plus 3 minus 5. Find the inverse of that function. You are good to go. See you guys tomorrow in class. Have a great day.